Hi, everyone. I've created Brokk because I believe two things that I think are underappreciated by most people and even most engineers. The second of which is more controversial than the first, I think. But the first is that AI is already smart enough to work in large code bases in terms of being able to understand the problems and being able to solve them and generate the right syntax and the right API calls and the right using the dependencies correctly. It's smart enough to do that. It has the raw intelligence to be able to do that. Uh, the reason why that some people don't believe that, and I've illustrated that with kind of two sides of this. On the right is someone that I pulled off of Twitter, just represented, nothing against this person in particular, but kind of representative of the school of thought that AI can't do this. It doesn't work. And then juxtaposed with that, you have Peter Levels, who basically vibe coded a multiplayer browser-based airplane game, and everything worked. And he was just delighted with this. Peter is a programmer, but he's not a JavaScript programmer. He'd never done 3JS or any of that stuff before. That was all coming from the AI. So how can these two opinions exist simultaneously and both of them be very convinced that they're correct? And really, it comes down to the context window that large language models have, that you're limited to roughly a million tokens with Gemini, which is one of the larger contexts that you have available, which corresponds very roughly to about 10,000 lines of code. And once you start getting past that, and in later posts, as Peter grew his game out, he started running into this limitation where once your code base doesn't fit in that 10,000 lines of code, then you have to start leaving things out. And if you leave out the wrong things, then the AI can go very, very sideways. And that's where this viewpoint illustrated on the right comes from. And so Brokk is designed to solve this problem in the first place. That's the first reason for Brokk existing, is to put the correct context into the available window for the AI to work with and solve your problem with. So the second thing that I think may be more controversial is that this model of an AI assisting a human, but the human is still the one reading the code at human speed and typing changes at human speed, and getting tab complete from the AI, but still fundamentally being this model that's existed for 40 plus years of reading through code and changing it in an IDE that's designed for humans doing that. That's the wrong way to build code today. The correct way is to have AI doing the tactical syntax oriented changes and even some of the planning around how to do larger refactorings, but with the human developer guiding it and supervising it and telling it what to do and correcting it when it goes off in the wrong direction. And so those are the two things that Brokk is designed around. So I'll give you a quick tour of Brokk and show how that manifests in practice. So the core of Brokk is here in the center. That's the workspace. And this is where you put code and make it visible to the AI. So the AI doesn't have access to anything outside of the workspace. So it's a very explicit design, as opposed to other tools where you give it instructions and then the AI goes off and tries to find relevant things. But if it finds the wrong things, then you're kind of out of luck. And there's very little visibility into how it decides what it chooses. So Brokk is designed around, you have maximum visibility, you know exactly what the AI sees, and that means that you can troubleshoot it. That means that if the AI goes off in the wrong direction, you can see, oh, it didn't know about the correct API. Let me add that to the workspace and correct course. But that doesn't mean everything's manual, because the second design principle in Brokk is to give you as much help as possible in setting up that context for the AI. So there's several ways that we can do that. Starting from the most explicit. The most explicit, you can edit a file, and you can also read a file. And the difference is that, if you read a file, then the AI will not be allowed to edit it. And I wish this weren't necessary, because my only one way to do it, Python loving brain, would prefer to just have one way to represent files in the workspace. But it's just too useful to be able to tell the AI, hey, I want you to understand what's in this file, but I don't want you to touch it. And so I've tried a couple times to remove it and said, hey, maybe the AIs are smart enough now that I don't need to make this distinction. And both times I've had to put it back in. So maybe in the future, I'll be able to take that out. But for now, it's useful to make that distinction. You can also summarize files, and this is most of what you have in your workspace, in my experience, will be summaries. And the difference is, I'll show you an example. So let's view Context Manager, which is one of the core classes in Brokk. So we're just going to view that. And so that's just 1,500-ish lines of code, as you'd expect. But if we ask it to summarize it, then we only have 150 lines of code. And that's typical, by the way, that you get down by about an order of magnitude. And what that looks like now is, instead of having the raw source code, we've just taken this summary, or this skeleton of the code inside. And so you have all of the signatures, and below the methods, we're going to have the fields, but none of the implementation details. And this is enough for, in almost all situations, for an AI that wants to call into Context Manager to be able to do so without hallucinating, because you've got all the methods available there. And the reason why we include private methods, by the way, is because it's useful for helping it understand a little bit about what's going on in the implementation without providing the full source code. So it's a bit of a compromise. So that's a summary. And I'm going to take that out of the context, because we're not going to want it in a bit. And then some slightly more sophisticated ones, we can do a symbol usage. So let's look at get analyzer, which is a method in the Context Manager. And the analyzer is what we call internally the code intelligence engine. And so what this looks like now is, we've annotated it a little bit with the class and the file that the usages are found in. And then for each call into get analyzer, we've included not just like that, hey, it's called from method X, or even here's the line of code that calls it, but we've included the full source of the method that calls it. And what that does is, now if I want to ask a question about, hey, does get analyzer ever get called with a null class name, or then I can ask that question and have all of that in the context for the AI to answer it intelligently. Or if I want to do a refactoring and I want to say, hey, transform get analyzer from something that takes one parameter to two, and here's how you decide what the second parameter is. Now we've got all of those call sites available with the surrounding source so that we can do those refactors intelligently. So we're going to take that back out as well. And then we can do a call graph to and a call graph from. And the difference between that and the usage is just a single level. It's just what are the first degree removed of calling that function. But if we try to do the same function here, get analyzer, whoops, then now, because we're going out to depth 5, we're not going to include the full source at each level, but we'll include just the code that makes the call at each level. So we have context_manner.getAnalyzer. That's how we get that's how it's called from the context agent constructor. In this case, now this one's called from preview text panel, which is called from search agent, which is called from, and so forth. So that can be useful if you need to follow where instances, or where parameters are coming from in the call graph, for instance. So those are the explicit. You can give it a starting point by using one of these workspace manipulation commands. The other way that you can get context into the workspace is by using one of the automated or semi-automated suggestions. So now we're going to get to a little bit of the live demo part. So we have a minor bug that I want to fix where, and I'll show you the line of code where it comes from. So let's just look at a file. I'm going to look at the edit block file, and when as part of making changes that you've asked the AI to provide, when it creates a new file, we're going to add that to Git. And so you can see we've got this if is create new, then we're going to add it to the repo, and then we're going to print out just as progress, hey, we added this to Git, just so you know what's happening. And so that's going to appear system output, that's going to appear over here. Now the bug is that if for some reason the AI doesn't make all of its edits to that new file in a single pass, if it does, if it creates the file and then it makes a second edit to that file in the same pass, then that line of added to Git is going to get printed twice. So that's the bug, and so we want to fix that. So I'm going to describe the fix that we want to make, and then I'll show you how we use that to get the context into the workspace. Add, or rather update, the add to repo method in git repo to return a Boolean. It should return true if the file added was not already in the repository. Use this return value in edit block to only print out the added to Git method if the file was truly new when we made the call. So if I were going to send this to a human in Slack, it's a little bit garbled because I was doing it off the cuff. But this kind of disfluency, where I stumbled over my words a little bit, is not a problem for LLMs to deal with. So there's some ways that you can confuse the LLM by adding noise to its context, but that's not one of them. So I'm not going to worry about that. So the first way that Brokk helps you, we'll call it semi-automatically add context, is these quick context suggestions below the instructions. And so as you type or when you dictate instructions, it will do a quick pass across the project and try to infer which files are relevant to your instructions. And in this case, it's got two of the 6 suggestions are actually relevant to what we want to do. So the first is edit block, which I showed you earlier. That's where it's getting called. So we do want that in the workspace. And then the other is git repo. And it looks like we've got a bug in the user interface here because I right-clicked on edit block and it added git repo. So something about the coordinate detection didn't quite work the first time around. So I'm going to make a note and fix that next. But for our purposes, we've got git repo, we've got edit block. And when you make changes to the workspace based on the suggestions that it gave you, it doesn't rebuild its suggestions, because otherwise maybe this one is something that I want to pull in, and if we rebuild it, the LLM might not resurface it again. So the 2 ways that we can get it to rebuild, one is by making sufficiently distinct changes to our instructions, and another way is by adding something to the workspace that doesn't come from here. So I'm going to try the second one of those, and I'm just going to do, let's just edit Brokk.java, which is not related to our problem, but that will let us ask it for new suggestions. And in this case, it's not actually giving us anything new. So I'm going to drop that, and we'll try the first thing that I said. One way to make sure you have sufficiently different instructions is to delete it and paste it back in. So now it's rebuilding its instructions, or rather its suggestions. And now, since we already have iGet repo and edit block, it's going down its list of relevance. And now git repo is showing up, which is the concrete implementation that we want. And so we can add that. So now that's one way to get semi-automated context in your workspace. So let's drop all of that. And I'll show you the next way, which is to use deep scan. So deep scan is doing something very similar to the quick context, but quick context is optimized for speed because I want it to be giving suggestions as you type. Excuse me. And deep scan is just doing the same thing, but with a smarter model. But the penalty is that it's slower. But since it's explicitly activated, I'm going to give you a dialog that says, hey, I'm not just going to give you this bar of suggestions, but I'm going to give you a dialog and say that the model, the LLM, thinks we're going to want to edit these 2 files and summarize this one, which is actually a good suggestion because the way we represent files internally in Brokk is with this class called project file. In this case, I'm going to leave out the test that it's suggesting, but I'm going to take those suggestions, and then we're going to see if we can get the quick context to give us iGet repo again, the interface. And we didn't get lucky. So I'll just add that manually. And then I think we're ready to go to the races. So I'm going to go ahead and click code, and we'll get its response back. While it's thinking about that, I'll describe some of the other things here, some of the other actions you can take. So ask is for as it says on the tin, it's for asking questions about the code in your workspace, but not make changes to it. And just like I mentioned up in Workspace with the edit and read, I wish I didn't have to make that distinction. I also wish I didn't have to make the distinction between code and ask. But too often, when I'm just asking a question, the LLM will try to solve the problem for me and start editing code. And that's not actually what I wanted. So I split it up into two actions so they can't get that wrong. Search is for doing, it's basically code RAG. It's retrieval augmented generation for finding code in your project relevant to your instructions or to your question. And the difference between search and deep scan is that deep scan is doing it in one pass. And so it's a hard-coded algorithm that says, take summaries of everything in the project, give it to the LLM, and ask it to tell us what's relevant to the instructions. And search inverts that design. So instead of having this hard-coded algorithm, search is an agentic design where we give the LLM a bunch of tools like search for symbols or give me the summary of a class, and to use those tools to answer the question by exploring the code base. So it's much more open-ended, and it needs a smarter model to run it effectively. Architect is also an agentic design where Architect can call any of these other tools as well as the workspace manipulation commands to solve larger multi-step tasks. And the way I mentioned that you do need smarter models for some of these. And so that's where this model configuration comes in. And here's how I have this configured most of the time. Sometimes I'll bump the Gemini code reasoning to high. Usually I leave it as default. And so each of these models basically corresponds to one of these buttons. The main exception is the edit model. So the edit is for performing code changes that are proposed by the architect. And code is for performing code changes that are proposed by a human, like we just did here. And the reason why those are broken out, and you can see that in my settings here, is that generally, almost always, the architect makes its instructions much more detailed and much more thorough than I as a human have the patience to do. And so if the architect's going to go ahead and do that and give it those very detailed instructions, you don't need to have as high of a reasoning effort when you're making the actual code changes. So I mentioned that search needs a reasonably intelligent model to drive it because it's this agentic tool-based design. Architect as well. And so the main models that you're going to want to use there are going to be Gemini 2.5 Pro, Claude 3.7 Sonnet. Those are the main ones. Now, O3 is actually the smartest model on the market right now, but it's really bad at tool calling, unfortunately. So if O3 were better at tool calling, then I would definitely put it in charge of being the architect. But since it isn't, the Gemini 2.5 with reasoning on high is the best that I can do. Some of the other changes that you might want to make, depending on partly your own preferences, is making Claude 3.7 the model for writing code. Basically, Claude 3.7 isn't quite as smart as Gemini 2.5 Pro, but it is better at following instructions. And so if you're going to do kind of a dance between using Ask to make a plan and then using code to implement that plan, then that's a reasonable choice. And that's my colleague Lutz's preferred way to set things up. For me, more often than not, I have a pretty good idea of what I want it to do. And so I'll YOLO a little bit and just use Gemini directly, either in default or in high reasoning, without generating a plan first with Ask. But I definitely recommend, if you're not super budget sensitive, definitely recommend using O3 for Ask. It is the smartest, and for that reason, it's the most useful for that. Very surprisingly good at just one-shotting bug root causes, just from description and having the right code in the workspace. It will get it a surprising amount of the time. So that's the basics of Brokk. Our edit here completed quite some time ago. So let's just look at what it did. So we asked it to make changes to the Git repo to make the add method return a Boolean. If previously tracked files contains, then true. Otherwise, where we default it? We default it to false here. That looks reasonable. And then I opened the current state rather than the diff. And then we look at where it changed it. If it's truly added, then output, yep, that's what we wanted. I'm not going to look at the interface. I assume it got that correct. And the build completed, which suggests that it did get it correct. So we can go ahead and commit this. So that's the basics of Brokk. Another video, I'll show how to use Brokk's Git features and use that to pull useful things into your workspace. But this is long enough for now. So thanks for your time, and I hope you try out Brokk.